ओके, कौन कौन है यहाँ पर? चावी है, समर्थ है, शिवम है, कनव आ रहा है। ओके, शिवम तेरे पास राइट्स देने के वो है ना? हेलो, मेरी एम आई ऑडिबल? हेलो, एम आई ऑडिबल? आवाज आ रही है मेरी?
या दिव्यांश।
ओके ओके।
हाँ हाँ दिव्यांश भाई, अब क्या बात आ रही है?
सो काइंड ऑफ ये लास्ट है अपना, जहाँ पर हमको रोना है लोगों को अटेंडेंस के लिए बुलाने के लिए। इसके बाद से तो सब ऑफलाइन ही रहेगा।
यस, होपफुली।
और उसका फ़ायदा ये है कि गुडीज़ हम दे सकेंगे, ये जीडीएससी में काफ़ी आसानी से मिल जाएगी। ये है, शिवम कनव को बुला दे और मैसेज फ्लोट करवा दो जूनियर कोर से।
ओके।
Shivam Kanav, kindly give the rights to Mr. Subhrajyoti and then he can share his screen. Hello, sir. Are we audible to you?
Yeah, let me switch on my camera as well.
Yes, sir. Also, you can share your screen so you can just check if the functions are working or not.
I hope it's visible.
Yes, sir. It's perfect.
Let me load up an emulator as well.
Sir, if possible, can you just increase the font size?
Yeah, I'll do that just a moment. I hope it's visible now.
Yes, sir. It's perfect.
Yes.
So, guys, we'll be starting at 7:05.
I'll just be back in a moment.
For sure, sir. So hello everyone and welcome to the third session of Android Study Jams. I hope you are liking it right now. And let's get to know more about data persistence and Android Jetpack Work Manager API. We have Mr. Subhrajyoti Sen with us who has been guiding you since last two sessions. And we have the third and last session on right now. Okay, Subhraj sir, the screen and the stage is yours and you can proceed.
Thanks. So, hi everyone, and thanks for joining in. So I'll start off this session with a bit of an introduction to REST APIs, how you can use, I would say, a library called Retrofit to get JSON data from the internet and how you can parse it and show it to the user. So that's the first thing we'll do, and then we'll look at how you can store data on your device as well. So first thing you should know before starting with any of this is Android has this concept of permissions. If you would have used Android apps, you would notice that if you open a camera app or a gallery app, it will ask you for permissions to see your photos so it can access and show it to you. If you would have opened Google Maps or Swiggy, Uber, any such app that uses location, you will be asked for location permission. But then you would have never noticed some app ask you for internet permission. So that's because there are two types of permissions. One you can consider safe permissions and other dangerous sort of permissions. Now, safe permissions would be something like connecting to the internet. That's usually expected of all apps and not something that will throw the user by surprise. And you're not taking any user's data or private data just by connecting to the internet. So you can just define the permission and start using it. But if you think of things like location, access to contacts, access to calendars, access to files, accessing camera. These are all resources that are private to the user, and the user should know when the app is trying to access them. So you can think of them as dangerous users, so dangerous permissions. So safe permissions don't really require, I would say, explicit consent from the user or approval from the user, but dangerous permissions do need. To ask to actually declare that an app uses certain permissions, you have to specify it using the user's permission tag in the Android manifest.xml file. So it is this file. If you go to app manifests, this is the file. So if you wanted to, mention that your app uses a certain permission, I'm not sure why internet didn't. Yeah. So this tells the system that this app uses the internet permission. It doesn't grant it by default here. For that, you would have to show some sort of a pop-up to the user and ask the user for permission. But for internet, that's not the case. If you were to show something like, let's say something to do with location. Let's say I want the users find location. So like some more accurate coordinates. In this case, I wouldn't directly get granted the permission. I would have to ask the user with a pop-up. And I'm sure you would have seen that pop-up in a lot of apps that you have used. Let me get rid of this. So this is what we use to get, I would say, mention internet permission. OK, so here you can see that the protection levels by different permissions are like normal, signature, and dangerous. And as I mentioned, for normal, you don't really ask. You're granted it whenever the app is installed, compared to when you see in dangerous that it is only when the app is running, it has to be granted by the user. And you can also see the column about must prompt before use. This is the dialog that shows up to the user asking for the permission. And you can see examples as well. For dangerous, it would be call phones using which you can call a certain number, getting access to camera, accounts, contacts, calendars, anything such like that. But things like, for example, getting access to the internet, Bluetooth, vibration levels, those are fine. I mean, it's fine if your phone starts vibrating to notify if an app without asking you first. It's very easily configurable. So you have these different types of protection levels, and there are different rules that are applied to each of them. You already took a look at how you can specify permissions using this uses permission tag and mentioning the name of the permission. If you go back to Android Studio, these are actually predefined by Android. So command plus click will actually take you to the place where it is defined. So this is the permission that we're asking. And you can see that there are so many types of permissions. Some are deprecated, that is, you're not supposed to be using them, but you can see all types of permissions in this class. Like you can see read logs, read phone numbers, read SMS. So there are a bunch of permissions you can use. Read call log, read call tag. If you want to get an idea, you can just come to this class, and anything with the prefix Android.permission is a type of permission that you can use. Now for internet access permission, you already saw the first type of permission, that is the internet permission. The second type here mentioned is the access network state. Let me check if I have noise cancellation on. Yes, I do. Okay. So access network state is a separate permission using which you can figure out whether your app is connected to the internet or not. So just by the internet permission, you assume that you have access to internet and you try accessing resources on the internet. But what if you wanted to check whether the app can be used without internet or not? You have just seen that some apps, if you launch them without internet, they won't work. Some would work. In some cases, if you click on a button, it would tell you that you're not connected to the internet, and only once you connect, you're able to use that feature. Access network state is a permission that these such features use. You mostly won't be using access network state. Internet is enough a permission to start with, working with APIs on Android or REST APIs for that matter. Yeah, an example of asking for dangerous permission is a Notes app is asking access to contacts. This might be suspicious to many users. So in that case, it's your responsibility to give an explanation of why you are asking for the Notes permission, and you'll have to show such a pop-up. This permission system was introduced in Android Marshmallow, which is API level 23. Below that, all permissions are granted by default, but after Marshmallow and above, you would have to explicitly ask for permission from the user. And if the user clicks deny, it's up to you to figure out how your app should behave. It would be a very bad experience if your app started crashing as soon as they denied a permission. Your code has to, I would say, have conditions in place that in case some of the permissions are denied, how your app should behave. There are some best practices, as in only use the permissions that your app needs to work. If you're a Notes app, try not to ask for contact or location permission unless you have a feature where the user can attach a location to a note. If it's a simple note-taking app where you store text, don't ask for contacts, don't ask for location, don't ask for permission to read SMS unless you have a feature where you read the SMS, create a note out of it. Right, so use only those that are needed by your app. You have to pay attention to the permissions required by libraries. You might integrate a library that has a nice looking camera that you get out of the box, but then that library is adding a camera permission to your app. So it's not about the apps that are requested by your particular app, but also by the libraries as well. I can skip some of the slides here. Yeah. So the next is, now that you know about permissions, you need to be able to use the network permission to get actually some data from the internet. So here's where Retrofit comes in. Retrofit is a networking library that you can use with the Kotlin or Java project. And it gives a very nice interface, a very nice way of defining what are the API calls you can make, what are the return types, and also attach some sort of a converter. So whenever you try to get data from the internet, it's usually in two formats. One is JSON and one is XML. I'll show you an example. This is a pretty raw image, so let me just copy to a JSON format that I have inside Android Studio. Okay, so this is what a JSON file looks like. It has key value pairs, and it's a collect. It can be a collection of key value pairs, or it can just be one key value. Here you have an ID, and you have an image attached to it. Let's try opening the image as well. Okay, this is an image from Mars. I'm guessing Mars, yeah. So that this is what a JSON, I would say, file structure looks like. But when I'm using Java or Kotlin, you can't directly use mm, JSON data. You would have to create some sort of a JSON reader, which can go through this file, figure out what are the key and value pairs, and then you can fetch data. What Retrofit does is you can use converters that convert this JSON formatted data into how you would construct classes in Java or Kotlin. We'll see an example of this. Why you would want to use Retrofit? Technically, you don't really need much reasons. Retrofit is the almost de facto standard in the industry. It is built on top of OKHTTP, which is a very popular and really reliable library, which is used by Android itself. It gives you a lot of additional features. For example, you can cache certain responses. So if you made a network request and it was not available, you can get some data offline and return it. There's connection pooling, where you don't create a new connection every time you send a new request, but rather you have a collection of such collection of connections which you can reuse, because creating new connections is expensive. And it sets you free from a lot of boilerplate code that you need to just start using network responses. We will get to this part later, adding the dependencies. So let's take a look at what are the components of API or a REST API, right? When you make an API call, there are 4 types of calls that you can do with the REST API: get, post, put, and delete. So first, if you think of get, I think there's a table here. Yeah. So you can see that the URLs are almost the same. This part of the URL is called the base, or the host name. The second, these are called endpoints, whatever comes after slash. And if you have anything with a question mark, something equal to something, the question mark represents that from here on, we are passing in query parameters. The word to the left of the equal to is the query key, and to the right is the query value. Let's see if there are examples of get, post. Okay, we'll just come back to this. So get is whenever you want to get some resource from the internet. Let's say you want to get an image. Let's say you want to get a list of today's trending 10 pictures. You are asking for some information. So in that case, you'll use a get request. So you're getting a response. Post is when you want to create a resource on the internet. For example, you created a profile on a social media website. You would be making a post request, which adds a new resource for you on that website. Right, so that is what a post request does. Then there is a put request. Put is when you want to modify a certain resource on the internet. So let's say you created a social media profile, but then you want to change your name. Once you change your name, you are not creating a new resource for you, but rather you're modifying the existing resource. In that case, it is a put API call. And delete, as the name suggests, is to delete a record. Let's say you posted a tweet and then you realize you shouldn't have posted it, or maybe there was a typo. And since there's no edit feature on Twitter, you can either just mention that you made a typo or you can delete it. So in all these cases, delete is the HTTP, I would say, request type that will be sent. Here are some examples. Like, for example, if you want to get a list of all posts, it's the get API. If you want to get a list of all posts by a certain user, or if you want to search for a post using a filter, all of them are just fetching resources from the internet. So they're GET API calls. But if you look at the other example, which was post/new, so you're trying to create a new post on that website, it will become a post method. So this is what Retrofit, I would say, does its magic. You have an interface, you can name it anything, and then you have these different methods. Okay, then you have these different methods. Now, if you remember from the previous session, this part of the method is a method name. Fun represents that this is a function. We will go to suspend in some time. Let's ignore that. And there's a return type of the function as well. So if you want to get the list of posts, it will return a list of the type post. If you think of similarly, if you want to list by user or search for a particular item using a query, you'll also get a list of posts. But when you're creating a new post, you're creating only one single post. So you'll be returned a post. Now, let's look at these things written before the methods. Uh, Anything with at before the word is an annotation. So it can be a bunch of things: at override, at get, at deprecated. It's just an annotation. And there is actually a program which runs whenever you're building a code. It's called an annotation processor, and it figures out what annotations are doing. So in this case, let's compare it to the other slide. Here, this is your base URL or the host name. This is your endpoint. And if you remember, these were your query parameters. If you come here, you can see that these are set as get annotations. So at get, because they were meant to be get API calls. And creating a post is a post API call. So it's post. And these are the endpoints. If you remember posts, post for a particular user ID, post/search for searching with a filter, and post/new. Here you will see that you're using curly brackets. That's because this endpoint is not always the same, right? If you want post search, it will always be post search, no matter what you're typing. But if you want to go for a particular user ID, it will be /post/123, or maybe slash your Instagram handle, right? It will change for every user. So in this case, this is a sort of parameter you can use where the method takes a parameter. The parameter can be named anything, but it also has a path annotation with the same string here. So what the annotation processor will do, it will look for the method arguments or method parameters. Look for this path annotation and its value. Replace that in the get string or whatever get post, whatever you're using. It will replace this. So if you call list by user with say 1, 2, 3, 4, the annotation processor will convert this to post/1, 2, 3, 4. You're passing a string user ID, which is fine. Here, if you see, you use the path annotation. Here, you're using the query annotation. Query annotation will just add the question mark. This will be used as a key, and whatever value passed will be used as a query parameter value. So if whatever you give here will be post/search, and then you would start with the filter query key, and then whatever value you want to give, it will be there. And it will return a list of posts. And whenever you're creating a post request, you usually pass in a body. Body represents the data that will be used to create that resource for you on the internet. Here you would create a post. A post would contain again what a user ID and maybe an image URL. So whenever you're creating a post, you're posting a link, you're creating this post object and passing it an annotation body. Now, if you notice here, we haven't specified the base URL yet. We will do that now. So to create a retrofit instance, there's a builder pattern. You call retrofit builder, and then you pass in different data that you want to keep adding. So here you pass the base URL, which is https:// This is the base URL, which is common for all the requests, right? So instead of repeating it every time, you're just passing it as a base URL. HTTPS is the schema that is used, and example.com is the host name here. There's also a function called converter factory. Here you can give access to different libraries that can convert JSON data to JSON or XML data to some other format for you. And then you call build, because that's how a builder pattern usually completes. Then using this retrofit instance, you call the create method. You pass in the name of the interface with Java class of Java. Now here, the simple service is the same class, is the same name as the interface here. Okay, so once you do retrofit instance.create with the class, you will get an access to service. Now on this particular instance, you can start calling these different methods like list post, list by user, search, create, etc. And you see the suspend keyword here. It's a part of suspendable functions in Kotlin, where let's say you start a work and you suspend from that place, like you suspend the working of that place. Whenever the data comes back, you continue executing. So you're suspending that execution. You're letting the request launch. When the request is back, you continue the rest of the operation. And this is how your normal structure would look. You have your app UI, the view model. We will take a look at view model shortly. It makes an API through Retrofit. Retrofit makes an HTTP response to the server. It gets data back, passes it to Moshi. Moshi is a library used to convert JSON or XML to Kotlin classes, and then it is passed back to the view model. Now, if you remember the converter factory method that we had, it just helps us convert from one response type into class objects, which can be Java or Kotlin. And you can see there are different formats that are supported: JSON, XML, protocol buffer, scalars. Don't worry about the other two. You just need to know about JSON and XML. And here comes Moshi. So like I said, Moshi converts a JSON response into a list of objects. In your case, list of posts. It's converting JSON into objects, and you can also convert both this. You can take a list of objects and make it a JSON response. Because when you call this post method, let me see if I can find it. When you call this post method, actually passing in an instance of post, but your server won't understand that, right? Server can only understand JSON in this case. So Moshi will convert this post into JSON while making the network request. Okay. Now, how does JSON know, or how does Moshi know how to convert between your Kotlin class and XML? So first you define a data class. If you remember, data class is a way of representing data. Here you have a title, description, URL, thumbnail, closed captions, etc., etc. And these are all of type string. You added the @JSON class annotation to this particular post so that Moshi knows that whenever it sees a type post, that it can convert it. What it'll do is it'll look for title as a title key in the JSON. It'll fill the data. Description, look for description JSON and fill the data, and it'll go on. Like this would be how a JSON code would look, and this would be converted by Moshi into this class. And you will see that each of these variable names is the same as the key that was in the JSON file. So We will see all of this code in Android Studio as well. But the way you would do it is you would create again a Moshi instance using the builder pattern. And you tell Moshi what kind of conversion do you want to do. So what you want to do is Kotlin JSON adapter factory. So it tells that you want to convert between Kotlin and JSON. Now, if you remember, I said about the add converter factory. So inside this method, you pass in an instance of Moshi converter factory to create along with the configuration you just created. The base URL remains the same. Here they just replaced with a variable, but then you can just pitch this thing directly here as well. And then you have the object API. Object class, which is an API. Now you can think of object as somewhat like static you have in Java, where you don't need an instance of the class to access its properties, but you can directly access it. Here you're declaring a retrofit service variable with type simple service. We're calling by lazy. So by lazy is a way of lazily initializing something. Normally you can initialize things as soon as your program starts, but you don't always need it, right? Like think that your app is Google, and you have one feature where someone can change between two types of currencies, maybe USD to dollar, dollar to yen, euro, or anything like that. Now, unless the user comes to your feature, there's no point of initializing these values and keeping them in memory. What bylazy lets you do it is the first time that this particular field, that is the retrofit service, is needed or is invoked, that is when this initialization will happen. So you can have something like only when this particular feature is used, I want to initialize these different values. So that's what lazy does. And if you remember from earlier, we just do retrofit.create and pass in the class name. Next, you just need to make the API call. Now, the thing is, you cannot make API calls directly on Android. That's because Android has this concept of a main thread, which is a thread that is responsible for showing you all the UI that you see on your screen. And all this happens on a single thread known as the main thread. Now, your network requests can take a lot of time. It can take maybe 5-10 milliseconds to maybe 1,000-2,000 milliseconds, which technically becomes 1 or 2 seconds. And you cannot keep your UI blocked for so long. You will get a pop-up from Android saying that your device is not or your app is not responding. That's because if you make an API call from the main thread, you're blocking that thread, right? You're not letting any other work happen on it. So Android needs to redraw your UI, I think every 15 seconds to give you a 60 frames per second refresh rate. So every 16 milliseconds, it has to keep redrawing a UI. If your API call blocks that particular thread for 2 seconds, that's a lot of milliseconds the app will be unusable. So you launch a coroutine. That is you can think of coroutine as a very lightweighted thread. And what this will do is this launches a certain work in the background. So we need to view model scope.launch. And in that body of that particular function, whatever you write happens on a background thread. So when you're calling this API call, it is happening on the background thread, and the main thread can continue executing how it was executing. Let's try seeing this in action. Let me stash this. Okay, I have the project most likely open in Android Studio. So yeah, I'll show you how the different parts are actually connected. So inside your manifest, you have the internet permission. Where do you have your, let's look for, yes, there's a network package, and inside that you have the Mars photo class, where you have specified this data class. You have a ID, and you also have uh, this val img src URL, which is just a string that contains the URL of the image. I think I need to sync my grid once. And you would notice that this img src URL is different from this img underscore src. In that case, Moshi can directly figure out how to convert between these two. So we use this at JSON annotation name and pass it a different name value. So JSON knows, or Moshi knows, that whenever it comes across img src inside inside a JSON file, it has to map to img src URL inside the Mars photo class. Then you also have the Mars API service, where you're creating a Moshi instance, how we did earlier. You also use a base URL. You create a retrofit instance with the base URL, and you also had a converter factory where you call Moshi converter factory.create, and you pass in this Moshi instance that we just created here. You also have this Mars API interface class, which has this get photo methods. Let me try increasing my font size if that helps you. Okay, let me close this. Here, you're calling a get photos, which returns a list of Mars photo. It's a get API call, and it is of the, I would say, endpoint photos. So if you want to see this work, what you can do is get, requests are pretty simple to make on a browser. Go to a new tab, type the base URL, type the endpoint, press enter. This might take a while, but yeah, you can see that we got a lot of JSON data. All we did is connect the base URL to the endpoint. And you will also see that this is a list. So you have one image here. The other, I think I'll have to increase my font size. Yeah. So there you have another object, another such object, or a photo. Here you have another such photo. So Moshi takes care of all of that. And then you also use this Mars API object class to create an instance of retrofit service lazily by doing by lazy and then creating that. Now, where exactly are we calling this get photos method? If you're on a Mac, you can press command. And if you're on a Linux or Windows machine, press control and then click on this get photos method to see wherever it is being used. It is being used in a view model. OK, so inside this view model, whenever it is initialized, this method is called, that is get Mars photo. Inside get Mars photo, you're launching a coroutine. In there, you are first, we will go to the status in some time. So first you're setting the status as loading. You put in a try catch block. That is a way of handling exceptions. So if something went wrong in your program, that's not just logical error, but also I would say going against how the program can run. You do a try and catch block, and inside the try block, you specify the code that can cause an error. Inside the catch block, you figure out that, OK, an error has occurred. How do I address this? Maybe you can fix it. Maybe you can show it to the user, bunch of things. So here you state Mars API status as loading as the initial value, and then you try getting the photos from the service, store them in this value, and make status as done. If anything goes wrong, the status would be an error. Now, what exactly is this underscore status? So here status is our live data. Now, our live data is a container that holds data, and it can be observed via view. So whenever something changes inside the status, inside my view model, my UI will automatically get updated. Let's see how it is getting updated. So if you go to fragment overview, you can see that we have an instance of this overview view model. Here what we do is we are setting it to the binding. Now, this is just setting this particular view model to an XML where you can directly extract data. and a lifecycle owner. So you can skip lifecycle owner for now. Let's try to run this app once, and we will see other parts of it as well. Okay, so since the first time I'm building this, it might take a while. Let's go to loading images from the internet. Now, why is loading an image from the internet a thing that needs to be discussed? Same reason that we knew about from API calls. Images can take some time to load. If you block the main thread, you cannot, I would say, do it efficiently, because images can take more time than an API call. If an image is considered like few hundred KB, it can take a few seconds depending upon your internet. Some people might be on 3G, 4G, etc. And also, image is a pretty memory intensive resource. If you think of your normal data that you use in your app, it will be few KB. An image can be 2-3 MB. It can be few hundred KB. Now, by default, Android won't have enough memory to suddenly start processing your image. So you would need a way of efficiently handling images as and when they're loading from the data, loading from the internet. So there are a few libraries that help you solve this problem. One of them is Glide. Others are Picasso, Coil. Coil is a pretty new entry, but then you have something like Glide, which has been there for a long time. It is focused on performance, and it supports images, video stills, and even animated GIFs. When you say performance or smooth scrolling, you can have like a list of items where each of them has an image. If you would have used Zomato, you would have seen such a UI where each of those restaurants have an image, or the food item has an image, something like that. The way you do it is add a dependency, where with the package with the actual library name and the version. I'll show you a similar example. If you go into Gradle scripts and then Gradle, scroll down, you will see so many implementation classes. This is why different libraries are added, which can be used by the program. In your case, the app. Here they're using Coil, which is another different library that lets you load images. Similarly, here Gradle is also a library that lets you load images, GIFs, etc. The way you load an image would be by calling glide.width, pass in some sort of a context. It could be a fragment, activate, or even a view. Pass in the URL that needs to be loaded into the load function, and also tell where to show the particular image. If you remember from the first session, to show images, we use an image view. So here we're passing in an image view, and Glide will try contacting the URL. If it's valid, it'll start downloading the data. Once it is done, it will put it in the image view. You can, okay, let's go through this. I was going to skip this, but we can. So you can use request options class to modify your request for the image. So it can be to crop, to apply transitions, to have a placeholder image. You would have seen apps that show you a temporary image while I would say the full image is being loaded. It could be something like I would say loading indicator. It could be something like a transition that's happening. We have a bunch of possibilities. The way you do it with Glide is you apply after load, you apply this. My bad. You call this apply function and you pass in request options. Here I'm passing in a placeholder and I'm giving it a drawable. You'll remember drawable from the session image views. And then you also have error where you're placing an error drawable. So what Gradle will do is as soon as it starts, give me one. Okay, wrong time for a sneeze. So you can call the apply function and then you can pass in the request options. So error will, in case there is an error while loading the image, it will show this error drawable in the image view. And while it is in progress, it will use the placeholder image. Now, error can be multiple things. Maybe the what do you say? Maybe the server didn't respond, or while it was trying to load the image, the internet connection dropped. There can be so many errors. So, if you want to handle also cases where you clicked on a button, it started loading data, but it's showing a loading animation. If it succeeds, the image that you wanted will get loaded, and if it fails, the error drawable that you passed here will be loaded. Uh, in this app example, they're using Coil. So let's take a look at this. It's something similar where Coil uses something called an extension function. So instead of using coil.load, it does on image view. So if you go to the definition of this load, it is actually an extension function. Now, an extension function is a way of adding a function to a class without modifying the class. Excuse me. So in this image view, you pass in the name of the class dot and you add a function. Now, since image view is not a class you created, you cannot modify it, but you can make it easy for you to add functions on top of image view. So this is what the load function here does. It goes on image view dot load. You pass in the URL that you want to load with a placeholder image and an array image. Pretty similar. I think I didn't execute the app. Are we missing something? Okay, maybe there's an issue with the API endpoint. I'm not sure why this isn't loading up. Everything seems to be working here. You have the view model. Okay, as long as you get an understanding, you can try it out later on as well. Maybe I missed the permission. Oh, permission is here as well. Okay, it could be something to do with the API. Maybe it's not responding for some reason. This seems to be correct as well. This is a 21. Okay, it's most likely an issue with the code provided for the code lab itself, so you can ignore that. But as long as you get an understanding of how you can create these interfaces with Retrofit to make API calls, or wait, this has internet connection, right? It does. Okay. So you can use Retrofit to create these interfaces. You can convert JSON files. As long as you can do all of this, you should be able to start working on small apps. For example, show the posters of the top 10 movies from this week, maybe in Bollywood, Hollywood, whatever. You could use this network fetching mechanism to fetch weather data, right? Take the user's PIN code. The way you would do it is if you go have an API like this. I'm just showing a mock example here, like a fake example, but then the way it would work is you would have a get method. You would say whether, like your endpoint might just be whether you would have a suspend function. You would say get. I hope my weather spelling is right. Never mind. Then you would pass in a query parameter, maybe call it pin, which refers to pin code here. And then you would just go to pin code string. You would get in a list of, or let's say you'd get something like weather data. So this is how you would create a weather app and use the endpoints to access data. Or you can use the exact same things here, like whatever you used Moshi, Retrofit, you can use the exact same. Almost the exact same code can be reused there as well. Okay, So we have been going on for around 45 minutes. So let's take a 5-minute break. After that, we'll start seeing how you can start storing data on your app so that if you use your app, close it, come back later, whatever operations you did, whatever was the, I would say, end result of that, that gets stored. And note app which doesn't store your notes would be pretty useless. So you would learn things like how do you store data onto your device, and how do you later get the same data to show it to the user. So the next time the user opens the app, they'll be able to see the data that they stored last time they had the app. So let's take a short break of, I would say, 5 minutes, and then we'll start looking into those concepts.
Sure, sir,
So
absolutely.
it's 7:51. Let's meet at 7:56.
Okay, sir, cool.
Okay, welcome back everyone. It's 7:57, so we can continue. The next topic I was going to discuss is how you could store data on your device, right? Now, I would say the out-of-the-box support that Android gives you to store data that is relational, that uh, the data that you're storing has some sort of relation to each other. It is structured data. Now, the solution you get for this is using SQLite. You can directly use SQLite to store data, but the thing is you'd have to write a lot of boilerplate code. You would have to create a lot of classes, make sure that everything you're writing by hand is actually correct and accurate, and it's not going to cause crashes later on. So there's a bunch of things that you need to do yourself. Now, Room is a library released by Google that kind of simplifies a lot of this for you. You don't have to create a lot of classes. The way you use Retrofit, you use annotation processors. You depending on what you wanted to do, whether it was a post, get, put, delete. You added these annotations. You provided, I would say, parameters to methods, got return types. That is a very programmatic way of doing things, right? That's what Room lets you do with, I would say, persistence, that persisting data on your Android devices. So uh, I would say Room has three major components. That is the Room database itself, which is again an SQLite database. You have something called entities. Entities are the actual data that is getting stored on your database. So if you have a list of movies, the movie is the entity here. And then you will have a collection of entities. And these entities will have fields that actually represent the data. What is the name of a movie? What is the URL of the poster? What is the rating of the movie? The release dates, bunch of things. And data access objects, DAOs, they are, I would say, they give you methods or they give you mechanisms using which you can get your entities, update them, delete them, modify them. You can do a bunch of things, right? And you can like insert new entities. Don't confuse this DAO with the DAO that goes on in the crypto world, different DAOs. This DAO is meant just for the Room libraries. So let me just increase my font size on the screen. Cool. I think this should be good enough for everyone. Now, remember when I said I would talk to you about how you can implement libraries? This is how you add libraries. So let's copy this part of code. And most of your libraries will go inside this build.gradle file inside the app module. So let's see how it looks like. Inside the app, if you expand this Gradle scripts, you will see that there is a inventory app and there's an inventory app.app. That is the app module. If you open this, scroll down, you will see a bunch of these already existing implementations. You can put in the same thing here. So implementation is just a way of adding libraries that you can directly access. KAPT refers to Kotlin Annotation Processor. So whatever annotations you'll be using, Kotlin KAPT is a tool that will process those annotations. And Room KTX is a, I would say, collection of extra utility functions, or rather, I would say, handy functions that you can use to make your experience with Room better. Now, where is this Room version coming from? It is most likely defined here. If you go inside the other build.gradle, you can see at the end of build script external, it is mentioned here. Now, instead of using a variable, you could also take 2.3.0, go here and keep pasting 2.3.0 everywhere instead of the dollar. But the thing is that is you're just, I would say, repeating yourself, right? You're not actually, I would say, being a programmer in the sense that you're not reusing things that are supposed to be reused. Now, since all of them are supposed to have the same version, you just define a variable here and you define a value to the variable, which is the common variable, which is here. Now, you should have noticed that when I wrote 2.3.0, this thing became yellow. That's because Gradle is trying to tell us that there is an updated version of this library available. So if I go here, just highlight it, you can see that it says the newer version of the same library is available. That is 2.4.0. We'll just continue with 2.3.0 because we don't need any of the new features. Whenever you change anything in any of the .gradle folders, you have to click sync now. Now Gradle will start looking at different places for these libraries when Gradle finds them. When Gradle finds them, Gradle will start syncing them. Gradle finished doing that. So Gradle actually looked for these libraries and downloaded them locally. It's still complaining a bit. So, I mean, if you want, we could upgrade it to, let's say, 2.4.0. Now, again, Gradle is actually looking for that. It downloaded the frameworks. And you can see that this highlight went away because we are the latest version of the library. And this is how you add libraries to your app. We have done this page. Now, this is how your entities would look like, right? Now you can see that this entity is most likely some sort of inventory for a supermarket where you have a table. Now each row talks of different items and each of them are entity instances. So yeah, your entity here could be a fruit. Your fruit will have an ID, a name, a price, and quantity. So that's all you need to show an inventory, right? Like my apples are priced at ₹4.50 or $4.50, maybe since it's a US example. And then you have 200 of such apples. If you think of it, these are all just data stored in a table. Each row is a new entry. Each column is just a field for that entity. And in the end, you also have a table name. Here it's just called an item because they don't want to store just fruits. They might store other things as well. The next thing you need to do is create such an entity. So let's do that. You can go to Java, go to your package name, right click, new package. So you're adding a new package. We will call it data. Inside this, right click, new, Kotlin class or file, call it item. Since it's again a class that just stores data, so we can use data class here. If you remember, we have an ID, which is an integer. We have a name, which is a string. I'll try increasing the font size here as well. Okay, and then we had val price, but this was, I would say, a float since we had something point something. And then we also had quantity. Now let's say quantity is an integer. We don't want to, I would say, keep like 3.5 apples or 201.5 apples. We want all whole numbers, so we are keeping it as integer. Now, if we think of this as an entity, we just need to type entity annotation, and you can see from the Android X room. This will tell room that this is actually a table that I want to store. But let's say my entity was called fruits, but I want my table name in the database to be items. So you can pass in a parameter, table name, and you can call it item. Even though your data class is called fruits, this data will get stored inside the item table. There's a bunch of things you can do here. Now, when you're storing data in the database, there has to be one field that is unique for all the items. And that is what is called a primary key. So a primary key is a way of identifying each row distinctively. So if you look for an primary key, you should be able to get only one row, not more than that. If you want to make ID as a primary key, you will do primary key. And this will store this ID as a primary key for this table item. Now, we might not always have primary keys of our own, right? Like if it's like, for example, an e-commerce item, you might have like some sort of a product code and a bunch of other things, but you are just running, I would say, a small grocery store where you don't have such an organized system where every item has an ID. You can pass in this auto generate. True. Like let's give it a default value. Uh, Auto generate true. So every time a new entry is added to the database, Room will automatically, I would say, uh, create a new ID and it will add to the new item that you're storing. So if the first item that you stored has 0, the second item will automatically become 1, 2, 3, 4. It will automatically keep incrementing it, which will ensure that all the items that you're trying to store have a unique primary key. Auto generate kind of takes care of that. So these are the annotations. These are the parameters which help you configure the annotations. Let's take a look at the. Not bad, we got most of it right. We use an integer first to show the primary key, a string for the item name. They use a double for the item price because they had like 0, 0. Oh, they had like 1 rupees and 99 paise. Sure, we can make it double as well. I hope quantity is integers for them. Yes. Yeah, you can see that we created all of this. We created a data class, item class with a data class. We use entity name to change the name of the table. We created a primary key, which is auto generated. We did all of this. Awesome. Now, another thing is the way we changed the name of the entity, that it was called fruits and we naming it item. Similarly, you can do that for each of these individual column headers as well. So you would call it a column info name. Instead of calling it name, you can give it something like product name. You can give similarly product price. So even though this is called name, it will be stored as product price in the database that we create. So we have done most of this. So now you know what an entity is. Entity is just it represents a table where your data will be stored. You know how to change name of the entity. You know how to give it a primary key so that you're able to search in a database, or not even search, just find an item with its ID, and how you can store different types of values. Next thing you need to create is the DAO, which is the data access object. A DAO is just a layer that sits between your actual application and the database and makes it easy for you to get data, set, I would say interact with data. Now let's create a DAO. Let's call it item DAO. Oops, I call it tab. Let's change it. Let's call it DAO. Okay, the DAO needs to be an interface, not a class, because it will be implemented later on internally in the code. I mean, in the generated code, we use annotation DAO. Pretty simple. Let's add a function for inserting. So use the insert annotation. It's again a suspend function because similar to how your network request took time, your database request can also take time. So if you block the main thread, your app will crash soon enough. So you want to do your DB queries in the background thread. So let's say add item. And you're passing an instance of item. And in our case, it wasn't called item, it was called fruits, I think. So it will be fruit. Fruits was a bad name to give. Let's just change the item itself so that we can follow along easy. Okay. So this is all you need to do is start adding an item. Now, what if the item you're trying to add already exists? Like you want to say that I have 200 oranges. Later on, you make an entry that I have 10 oranges. Right. You are not adding in new data, right? Because oranges already has an entry. What you technically should be doing is changing the number of oranges that you already have and not try adding oranges twice. Because then every time you keep adding, you'll have to check, okay, where are the different oranges and what's the total, which makes it, I would say, pretty hectic. Now, there's also this thing called an on-conflict strategy. It's again a parameter that you pass to the annotation. So what on conflict says is you ignore it. So on conflict is a case where you're trying to store something and the primary key already exists in the database. So if you already had stored orange with ID 3 and you're trying to store oranges with ID 3 again, conflict, this on conflict will tell room how to handle it. Ignore says that it will ignore the new entry and keep the old entry. If you go to other values, I just did command and click. You have replace, abort, fail, bunch of things. Replace will replace the old value with the new value. Similarly, if you want to delete a certain entry, you would go to add, delete, suspend, fun, remove item. Room will automatically take care of finding the item that you are trying to delete. So it will look for the same item with the primary key, match the other data fields, and it will try deleting it. Now, if you have heard of SQLite before or SQL queries before, you know that you can write queries as well. So for that, you can write something like a query annotation, and then you can type in your query. Let's say suspend and find get all items. This will return a list of items because you're asking for all the items. And the way your query might be is select star from. Let's check what is the name of our table item. Select star from item. I would say sort by. Okay, we'll get to know soon enough. I completely forgot SQL for a moment. And similarly, also have an update where you pass in again a similar instance and it will update the, I would say, the entry with the primary key with the new data. Similar to what you would do for put in an API call. Here you can see that we are performing an example query here where we're checking an item by ID. So select star from item where ID is equal to this particular ID that you passed here. It would look something like this. Select star from ID where ID equal to this colon ID matches the same ID that you have here. Here you have a get items function which returns something, and you have select star from item order by. This is the part that I missed out. So let's just put that. Order by name did not make sense here. So let's figure out what. Oh, we haven't told the DAO which values to use. I think that's the issue here. So here name was the name of our actual class, but for the entity, the name is product name. So we should be writing product name here. So we have created a DAO as well, and DAO gave us these functions. Let's also add the update function. If you wanted to get one by, like, for example, get item by ID, you passed in an ID. In that case, you will get a single item. The query would be something like select star from item where ID equal to. Now you can see that this ID is the same as this ID. If I wanted to call this product ID, you'll see that this becomes red. So this will also have to be product ID. It's similar to again retrofit where you did some sort of a mapping. Next, you would need to create the database holder. So let's call it app database. If you remember, we had talked about something called an object class, which is similar to static in Java, that you can access these methods directly. But I think let's clip it class for now and see what the code lab tells us. We did all of this. Okay, I'll just copy the final code here and explain to you step by step. Let me add the imports for all of them, and then let me explain. So if you define an abstract class and you extend from the room database class. Again, you use annotations here. So you have the add database annotation. Now here you're passing in what are the tables in your database. Now a database can have multiple tables. Here only one of the tables is item. If you had to think of something like a school database, you would have a table for students, a table for teachers, a table for the lab equipment, a table of all the rooms, so many, right? So this is the reason it takes in an array. But since you only have one table, we're passing an item. You have a version, which specifies the version of the database. Versioning helps you figure out how different different changes are occurring over the database over time, and also to make sure data is safe between two versions. Export schema is just an argument which tells Room whether that once it has figured out what your entity type and everything is, should it export it to a file or should it not? If you do export it, you can keep a reference of it always, saying that how the database structure looked on different versions of the database. You also need to have an abstract function with any name which needs to return a DAO. In this case, your DAO is called item DAO. Then you also have an instance here which stores which is the type of this class, the abstract class. You also have a function called getDatabase, which is inside this companion object. Companion objects are also like static blocks where you can call these methods directly without creating an instance of the class, as well as all I would say classes that I have to access, and I would say anything inside a companion object always get the same value. It doesn't, since it doesn't create an instance, it's not changing the value. All you do here in get database is if you check if the instance, you return the instance if it is not null. Otherwise, you create an instance using the application context, the database class, which is the same as this, and give a name to the database. So the item database that you're passing here, the database would be called item underscore database.db. You have fallback to destructive migration. So this is also a migration strategy that you give. Now, what's a migration? A migration is when you change the database version along with the schema, and you want to migrate the old database into the new old data into the new format. So migration just tells SQLite, how do you take the existing data and make it compatible with the new form? If you cannot do it, you can do something like destructive migration, that it will delete all the old data that's already exists in your database, and then you'll have to reinsert data. It's okay. Destructive migration is okay if you're just doing like some sort of testing and your code and not releasing it, because once you release it, you always want your data to come from the old version and go to the new version. Otherwise, your users will end up losing a lot of data. And you have this application context thing here. So to get an application context, you need to first create a custom application class. Let's go here and create something called inventory application. Okay, apparently inventory application already exists. Oh yeah, they already have a class for implement inventory application, which extends from the implementation class. Now, for this to act as an application class, you have to go to manifest and see if then yes. If there's a name attribute which specifies this, that is the full package name as well as the name of the class that extends application. So if I go to the definition by using command plus click, you will see that this goes to application. Now here I can have something like van app database by lazy. I want lazy initialization. I don't want to create the database as soon as the app launches, but rather wait till the first time I need it. App database dot get database. Application context, I think will most likely be this, which since it's inside an application class, if I ask for its context, will most likely get the application context itself. Now, whenever I want to add, remove anything to the data, what I can do is let's go to our view model. Do they have a view model here? Interesting, they don't have one. Let's say we go to the detail fragment. They have a navigator, cancel, they have everything. Okay, just to show you the example. What I could do is okay, I can't directly cast the fragment here. That's fine. We will try to create a view model and then get access to things. So let's get back to. I hope this part was clear about why we're creating all these different classes. The database class lets you connect everything together. That is your DAO, your entities, specify schema, version, everything together. We also did this bit where we created a database and stored it in the application class. Now, the application class is one of the first classes that gets initialized. So once that has access to the database instance, all of the, I would say, screens can also get access to it. Okay, they want us to create a view model. Sure, so let's go ahead and create it. Okay, so any sort of a view model will extend from the view model class. Here, it's taking an instance of the item DAO. So you cannot directly create a view model. So you cannot directly give this value to the view model either. So we can do this is by using a view model factory. So that I think is the next step here. Let's copy the view model factory. I'll explain the code inside it as well. So a view model factory extends from view model provider.factory, and it has to return an instance of your view model. So this is giving us a warning saying that it does not implement a member. So let's click on that red icon, implement members. This has a create method which has to return a view model. Okay. What we are doing here is we are checking if a certain class can be assigned as an inventory view model. If it can, we are passing this item dow as a parameter to this view model, casting it to this t, and this t refers to the class that we want the view model of. If it is not possible to do this, we throw an exception saying that we don't know anything about this view model class and hence we cannot construct it. To get an instance of this view model, you can go to your item list fragment. I'll just show you how to get the view model. Yeah, this is the way. Here you can see that we are using the factory. We are getting the application context from the activity. Once we cast it to this inventory application, I think this will be called app database. So we're getting an instance of the database. From that, we're getting an instance of the DAO. So we're creating this view model with the DAO. Here we can come and we can have functions like fun, add item. Let's pass in an item. Another DAO, just the item. You can use a view model scope. So our scope basically just tells the coroutine where it should launch. So this is doing it on a background that we're calling launch. And we can just do item DAO. Dot add item, and that's it. You will be able to use this to store the item. If you wanted to get an item, get item by, let's say, ID. So you'll just need to send an ID, which will be an integer. The return type of this will be an item. What you will do is, the way you could do this is view model scope dot launch item down dot get item by ID. So similarly, you can launch a coroutine and call these different methods of the what do you call the database. Now, if you think of room, there's also another important thing that you should know. I would say it's not an important thing, but rather it's a good practice. It's some. Let me see if I can find a diagram for this. Okay, there doesn't seem to be a diagram here. Yeah. No, this. Not sure which diagram it was from. Let me just check. It's something good to know. So I think it. Okay, it was in this club. Yeah. So this is something called a repository pattern. So the way a repository pattern works is you have your other, I would say, parts of your app where you have the UI. You have the view model, which acts between a layer between your data and everything and between your view. Now here we have this something called a repository. Now, if you think of the term repository in terms of English, a repository usually means a collection of some sort of things, right? Repository of books, repository of other things. Now, the advantage of the repository is once you have a layer that's a repository, behind it, you can do whatever you want. You can get your data from the internet. It can get the data from Room. It can get data from local files. But the way this works is it will hide all the details from the rest of the app. So the rest of the app will just say, hey, get me a list of notes. It doesn't care where you're getting the notes from. It knows that once you ask it for notes, you will give it the correct notes. What the repository internally does is it can do something like, for example, check the network to see if there are any new notes. If it gets the new notes, from there it will figure out, okay, like these are the new notes, so I should show updated notes, pass those notes to the UI. If internet thing failed, or maybe you're not connected to the internet, it can take a look at the database that's local, look for the nodes there, and then return them. So you can see that you are adding an offline support to your app that it can work offline, but the rest of your app doesn't care. The rest of your app just thinks that, okay, I asked for data, I'll get it. I don't really need to know whether you're connected to the internet or not. So once you start writing some app, you create some database, try reading up a bit more on repository pattern, look up some tutorials, and try converting whatever I would say way you have structured your files to something like a repository pattern, because that's a very good architectural practice. And I think that's it for today. You learned how to, I would say, create databases, how you can give it a schema version, how you can create different types of entities, create the DAO, connect everything together, and then use it in a view model to actually start storing data. I'll stop sharing my screen. And if you have any doubts regarding the session, I can take them up now.
Okay, sir. So that was very insightful. And do you guys have any more questions? Sir, are you taking up questions right now, or the event is over? Like the part you have to cover?
I think we can cover it. It's already been 1.5 hours, so I wouldn't really want to jam with more information.
Yeah, that's totally cool with us. Okay. So thank you so much, sir. I hope the audience of Bennett University enjoyed the absolute load of knowledge, and you showered it very well. And we will be seeing a lot of useful apps further with the help of this session. It was an incredible experience hands on the Android study camps. And guys, do fill the feedback form to give us a like your genuine feedback about Subra sir, about GDSC, and about this whole event going on. And yeah, at GDSC, we continue to be committed at serving you the best. And we cannot wait how you mold this experience forward. And we look forward to see you again with amazing stuff happening around. Have a great day. Thank you so much, sir. Thank you so much, everyone. And yeah, that's all for today. Thank you. Bye.
Thank you, everyone.